one today. We'll start it. We're not going to get all the way through our notes. But we're looking at vertex form. So vertex form, y equals a times x minus h squared plus k. So this is somewhat of a factored form that we might see the quadratics in. When you're looking at this, the ordered pair HK is your vertex. Axis of symmetry we know is the vertical line going through the vertex, so it would be x equals h. So we are going to focus on graphing these today. Now there are different options. If you weren't concerned with time, you could take any of these and graph it by first multiplying everything out and then rewriting it in the form we were using before. Okay, and that still works. How did we find the vertex when it was written in that form? Yeah, the thingy x equals the opposite over 2a. Okay, so we've seen them in that form. We could take all this and multiply it out to get that form, but that's going to be a little time consuming, and it's really not necessary. We can actually get our vertex right from here. So when I'm looking at this, the formula has the minus already. Okay, so you notice these signs don't match. Plus 4 is the same thing as minus a negative 4. Would you guys agree with that? All right. And then it had a minus 2, but the formula is plus. So that's the same thing as plus negative 2. Do you guys agree with that? So my vertex is negative 4, negative 2. Axis of symmetry is the vertical line going through the vertex. So that would be x equals the x value of our vertex, which is negative 4. Now this sometimes confuses people because they see a positive 4 and they want to say the x is at positive 4. How could you double check yourself on your vertex? We could do the thing. We can multiply it out and do the thing like we did before. What else can we look at? Could we look at a graph and double check it? You know, if I graph this, remember to graph it, you have to go to the y equals, clear out what's there. We have parenthesis x plus 4. Close your parenthesis, do your square with a minus 2. Now if we look at this, can we see that the vertex is at a negative 4, negative 2? So use that to double check yourself if you get confused on those. All right, number 2, the vertex. The vertex is HK, so we have the x minus 3, so the x value of the vertex is just positive 3. Do I have anything added on the end? So if there's nothing there, it's like a 0. So our vertex is is positive 3, 0. What's the axis of symmetry? 3. X equals 3. All right, number 3. What's my vertex? 5. Positive 5, and the y would be? Negative 4, because the formula is x minus h and a plus k. All right, and so the axis of symmetry would be x equals 5.
The minus sign doesn't make it negative?
It doesn't because it's in the formula. So if, like this one, the minus makes it negative because my formula has plus.
Okay.
Another way to think of it is like the inside is always the opposite of this number. So that's like a negative 5, so the opposite of that is positive. Number 3, do I have anything added or subtracted to my x? So what do you think the x value of our vertex is?
0.
All right, but then we have a plus 3 on the end, so it goes Positive 3. Axis of symmetry, x equals 0. Alright.
How come the other ones are negative at the end, but that one's not?
Because all these two both had minus a number on the end, and this one was a plus. Alright, so now we're going to do the exact same thing we were doing on Friday. So axis, symmetry, vertex, domain, and range, table, graph, the whole bit. The only difference is the original problem is written different. Okay, so to find our vertex, if we think about the formula, we can probably just look at it and tell. The formula has x minus, so since this is x plus, what is the x value of my vertex? Negative 2. And the y is supposed to be plus that, so the y value is?
7.
What's my axis of symmetry?
X equals -2.
Okay, so remember when we set these up, we set up our table, we put the vertex as the middle point, and then we did things smaller and bigger. And this is a good time to double check it as well. You know, if we're getting something different when we put this in, we know we made a mistake. So we go to our y equals, we're typing in a negative parenthesis, x plus 2 close your parenthesis, squared, a plus 7. If we go into second, and that graph button takes us to our table. So let's see if we got it. We had our vertex at -2, -2, 7. That was the point on here. Okay, -3, 6, -4, 3, -1, 6, and 0, 3. And you'll know if you have it right because these y values should be the same. It's a parabola, so you have your vertex and the others match up. So we plot this. Got we have -2, 7. Okay, so we plot all of our points. And why is this parabola opening down? Yes, we had a negative in front. We know axis of symmetry is just the vertical line that cuts it in half, and it should look the same on both sides. What's the domain always? What is the range?
X is, or y is greater than, or less than, or equal to.
Less than or equal to
Sounds good.
7, because that's our highest point, and then we hit things below it. Alright. Questions on that one?
On the calculators, how do you, when I do squared, it doesn't let me like do it. When I would put any square on there. Like I don't know.
Yeah, just use the arrow to
I swear I did that. I swear.
Yeah, just use the right arrow. Down won't work, you have to go right. Okay, any other questions on this one? Alright, let's try a few more. So number 6. Can you guys look at this and tell me what our vertex is? +1 because the formula is supposed to have the minus, and there's nothing on the end, so the y is 0. If you weren't sure if you had done it right, how would you check it? Look at a graph and see, is 1, 0 the point where we change direction? Once we have our vertex, that's the middle of our table, then we go smaller and larger. What's the axis of symmetry? X equals the x value of the vertex. So now we need our points. We go to our y equals, clear to get out what's there. 3 parentheses x minus 1 squared. Look at our table. Let me see our points. 1, 0. You can see it's like going up until we get there and going, kind of changes direction. Going down, going up. So our points, we have -1, 12. 0, 3, 1, 0, 2, 3, and 3, 12. Plot 1, 0, 0, 3, and 2, 3. The others are off my graph, but this is enough. Sounds like a great day to play baseball. Axis symmetry, dashed line going through there. What's the domain? What's my range? Greater than or equal to 0. Okay, so this is leading us into another idea. We are graphing these kind of using what we had done before, just picking out our vertex and doing the same thing. But there is another option. These are what are called transformations. The easiest quadratic equation is just your basic y equals x squared. And that is sometimes called the parent function. Transformations are ways that graph can change. So it's a change to the size or position of a figure. Alright, so I'm going to do just a little bit with this, and then that's going to be where we pick up tomorrow as well. So if I looked at this one, where is my vertex at? -2. What's my y? So if we do our other points, go to the table feature on your calculator. So when you put in -4, what do you get out? Everybody should be doing this. 4. -3 gives us -2, -1, 0. So if I plot this, so -4, +4. -3, +1, -2, 0, -1, 1.
Please dismiss baseball at this time.
Wait, do we need to have this finished?
1 through 6, you could work on it in advisory tomorrow. So if I'm doing this based off transformations, that black parabola represents the original x squared. How did it end up moving? It moved left. How much? It moved left 2. If I took points on the original, every one of those points moved to the left 2. What part of this equation do you think made it move to the left? We added 2 to our x's, which essentially took the graph backwards 2. All right. Let's look at another one. So if I looked at this one, my vertex, there is nothing added to my x. So my vertex, the x value would be 0, and the plus 5, so 0, positive 5 is my vertex. So use your table feature, and let's get the rest of these points. So -2 gives me -1, 0, 5, 1, 6, and 2. So how did this graph? It went up. How much did it move up? 5. What part of the equation do you think made it move up 5? The plus 5. So we saw when we added a 2 on the inside, that moved it to the left. When I added 5 on the outside, that moved it up. We are going to do one final problem for today. Let's make a prediction. What do you think that plus 1 will do to my graph?
Left one.
Plus 1. All right, what do you think the -6 will do?
Down 6.
Let's see. All right, so my vertex would be what? -1. -6. Okay, so we do our test points. Use your table feature. If we put in -3, we get
-2. -5. -5. And -2.
So were we right? Did our graph move left 1 and down 6? Yes. That's why the formula for the vertex is a little bit weird. When you add something to the x, it actually ends up moving it to the left. Subtracting it moves it to the right. Outside does what you think. Adding goes up and subtracting goes down. Tomorrow we're going to learn more about these transformations because we haven't covered all of them. We've only done left, right, up, and down. There are other things that can happen on our graph. For your homework, I want you to graph them the way we were doing these examples right here. We figured out the vertex, used the table feature, got our points, and drew our graphs from that. You are not ready to do all of this handout yet. So your homework is 1 through 6.